Welcome to part 2 of the Air King 4607. As you can see, I have it recapped with the exception of the mica caps here, which right now is disconnected because I need to test it, and a two reds and a green, I think that's 2.2 meg, is up in value, so I got to change that. And the rest of the resistors are okay. This is a brown, black, and yellow. I think that's 100K. That's not even on the schematic. It's not even on the schematic, which is downloaded from Radio Museum. They're saying 35Z5 for a rectifier in the description, but it shows a 35Y4, which is a loctal rectifier tube, not an octal, but this has the 35Z5 up here. So I can't find this 100K resistor anywhere on the schematic. So what I normally do is whatever's in the radio, when it looks original, I'll replace it with that value. So I have not yet tested the tubes. We've had some bad weather, and I'm just getting out into the shop today. Today being Wednesday. We almost lost power last night. It went down to 103 volts and came up and went down again 4 or 5 times last night. Usually that means we're going to lose power, but we didn't. But that don't mean we won't. Everything's good now, but it's going to be very cold tomorrow, which is Thursday. So all the other resistors are good. This one's right on the value. 470K is fine. There's 2 resistors that are off. This 100K, which is up in value, and there's 2.2 meg. So it looks like a 2-watter. I don't have a 2-watter. Most of my resistors, other than big power resistors, are 1/4 watt and 1/2 watt, and maybe 1 watt at the most. This radio used a few .047s, including one on the line bypass, but I did not have a line bypass safety cap of that value. I do not have it, so I'm going to have to order. That's the second radio that needed a .0, actually it was an 05 for a line bypass cap, so I replaced it with the yellow ones from Sal's. I didn't have it on the Y too, but me, I go either way with it. It doesn't matter. The Y or the X. X is across the line, the other one's going from the line to the ground. So on a radio like this, there are only 2 circuits, I guess you'd call them. You've got the neutral, which is grounded, and you've got the hot side. So whether you put it across that, use an X or Y, it doesn't matter as far as I'm concerned. But I don't have an 047 in these either. So I'm going to have to order that. Plus my .047s. I got 1 disc and 2 of the yellow jobs from Sal's. So I'm going to have to put an order in for that. I got to take an inventory and see what I need. Most of the caps I'm okay. 0.1s, I'm very good on that. These are the white jobs came out of the oscilloscope, the 400 volt. I just threw them in there because they tested good and they held 400 volts. So yeah, I'm hurting on caps. And 01s, I'm okay. So before I can even start recapping this, I'm going to have to put a big order into cells. As you can see, I got the speaker protected. The dial cord is, I'm not going to be able to do anything with that. There's a hole here in the chassis which would normally accept the dial cord, I guess. I don't know. Goes around here, I guess. I'm not going to be able to do that. I had thought of just taking the dial cord, going around here and going around the pulley, but I'm not even going to be able to do that. No, I'm not going to be able to do that. That's beyond me. I might try off camera, I might take a rubber band or something and try to go around here and stick it up and going around. I'll take the string off and going around so that when I turn the dial here, at the tuning dial, it will at least tune the condenser, the tuning condenser. I'm not going to worry about the dial here because I'm not going to be doing no dial cord. So I'm not going to worry about it. What I did on the volume control here, and the reason these are this is disconnected and this is disconnected is not only to check it. Normally I wouldn't even bother because they're usually good. Is I had to remove this control, and it was not easy because one leg of the switch, flashlight ain't with the powder to blow it to hell. If you can see down there on the bottom, there's the bottom contact of the switch, the terminal, has a piece of heat shrink over it now and a wire coming through right here, okay, that I added. The originally that was soldered right to a tube socket grounding lug from the tube socket itself. I had a hell of a time. I had to get this all disconnected. Then I took and pulled out, wiggling out the control by heating that up. And while I was heating it up, I was able to pull it away from the lug. In other words, the switch switched to ground, which is, I don't know why all these old radios were that way, but that's a hazard. To switch to ground, you always switch to hot side. Of course, years ago they did not have polarized cords or plugs. So, wiring it this way now, this lug that you can see right here, I'm sorry I have to take the light away because I can only got so many hands here. Where my finger is, that lug is going to take the hot wire from the power cord, and the neutral side will go to the chassis. So this will be a safe radio. It'll have a polarized cord and plug on it. So I can't do any more restoration on any other radios until I get some more capacitors. And I'm not planning on working on the Phillips right away anyways. Now the next step, I'm at a point now where the original electrolytic, as I showed you in the very early video, the first part 1, was this one here. You see, it was clamped down to the chassis by way of a 1/4-inch nut self-tapped into the chassis. So that'll be my mounting for the terminal strip that's going in here. Then the electrolytic goes in here. Now, this electrolytic is 3030 at 200 volt surge or 150 volts. Okay, 3030, but yet the schematic calls for, right there, 4040. So it may be a replacement, or that may not be the right schematic. Who knows? But we're going to put in, let's see, 30, originally was 30. So we'll probably put in 33 microfarad. I could go 47, but there's nothing in between that I know of. So I left these on so I make sure I know where they go. They may not reach the terminal strip, so I'll have to take the wire off and extend it. There's a mica here, which I'm not even going to disturb. I'm going to assume it's good. I've been checking the resistors, and like I said, there's 100,000 brown, black, and yellow. Right there, right straight ahead. Think you can see that. And it reads way up, but that's not on this. I can't find 100,000 ohm on this schematic. Okay. And the 2.2 meg, I know I've got it, but I got to move all this stuff in order to get at my resistors. So I wanted to, on this part 2, it's basically the way I'm going to be doing things pretty much from now on, is as I'm working on something, then I'll video it. I won't video it actually doing it, because it takes way too long. You know, for me, it takes way too long to do anything live, so to speak, by way of video. So I will video as I go along, as I progress with each stage of the repair. I will be testing the tubes. I will not be videoing that. And I'll be putting a cord in this. And there isn't very much else to do other than to replace that 2.2 meg resistor. I'm not going to worry about the 100,000 ohm resistor if it's not on the schematic. I'm not going to worry about it and probably leave it alone. And I tested the IFs, close as I can tell, they seem to be okay. And I may, off camera, and we'll give you a report on that, but that'll be the very last thing after I get the cord on and the tubes are tested. And any tubes that are bad I'll have to order, because I do not have any Loctals that will fit this radio. I might have a few Loctals, but nothing that will go in here. And the only tubes I do have is a 35Z5 and the 50L6, which is here. So I'll be able to replace those with no problem. So, after everything's said and done, and I get life out of the radio, I will take this dial plate back off camera, and to see if I can put a rubber band around the tuning condenser here, and it moves easy enough, and go down into, there's a hole down there, but the problem is the hole is over here and the shaft is over here, so the rubber band is going to have to be dragging on the chassis, but so does the dial cord. Anyways, my objective is to get this tuning condenser to turn when you turn the knob, because once it's in the case, you're not going to be able to tune it. I don't care where it reads on the dial, you know. This is the only way I can deal with it, because I can't do dial cords. I've said that so many times. I think you're getting pretty darn sick and tired of it. You know what I mean, guys and gals? All right, so I'm going to end this video now. I will be testing these tubes, and I'll be right back. So I'm going to test them now, and I'll give you a report on them. I'm not going to bore you with a video of that. So we'll get my B&K 606 out here and test all these tubes. Okay, the lock tools all test good. The 35Z5 showed a short as soon as you plug it in. So I replaced that and I double checked the new one and it's fine. The 50L6 was a new old stock. The original one had a short in it. Again, as soon as you plug it in the socket and you rotate the switch to, I can't remember what position. Okay, so this is a new old stock. This tests good. No grid emission and no shorts. Now, we will rotate this again. I can't remember where the short was on the old one, but this is a new old stock, GE, kind of a different base to it. So we're going to put that in the radio, so we're going to have all good tubes here. So this is going to conclude part number 2 for now. I'll be working on putting the electrolytics in, putting a power cord to this, and replacing the 2.2 megohm resistor, which is off value, which is right here. So we can get that back onto this pin here. And yeah, that was a job taking that out, because the terminal, one of the switch terminals, was down, jammed right up against the ground lug and soldered to the ground lug. So that was a little difficult, but I got it, because we want to switch the hot side and not switch the ground on and off the chassis. So there is going to be a little more work on this, but we're not too bad a shape. We've, like I say, I got to put the terminal strip in there, right here, and a couple of electrolytics, and I think we put the cord on it and we can try it out. So once I get the cap in there, the electrolytics, and get this resistor changed, and I tested this cap and it read on this meter here 0.173 nanofarads. That means nothing to me. I don't even know where that is on the schematic. It's off the volume control. Let me see if I can find it. Alright, here's the volume control here. That mica cap is off the high side of the volume control. Well, it's not here. Not sure. Maybe it's here. Maybe that's it right there. That's going to the bottom of the second IF. Alright, that might be it, because there's 2.2 meg. It comes off of that, and yeah, then the other end of that goes to the secondary of the first IF, and then there's a 0.5 to ground off of that bar. So let me see if I can get a value. It's 220 micro mics, 220 Mickey mics. You can see it disconnected right there, along with the resistor wire here, the lead. 220 micro mics, but I read I don't know, I can't remember what it was. It was a 0.17 something nanofarad, so that don't mean anything to me. But it was tested using these long leads on this meter here. So I could try the component checker in that. As a matter of fact, I think I will do that and give you a report of that. It's 196 puffs. Mickey mice. So it calls for 220. So I'm sure that's okay. So we'll just solder that back on. We got to tack it on because it's going to just barely reach on that, because I had to clip it off because I have absolutely zero luck trying to unsolder leads out of a terminal. So I just clip them off. And then I just tack them back on there. On this capacitor here, I was able to clean the terminal out and solder that in fine. This is 0.01 here, I believe it is. And most of these others are 0.47s. I just, for the heck of it, I had this meter out. The 2.2 meg is reading 2771. 2271. It just went out. I had to push the meter on again. 2772. So 2.7 meg. So it's up a little bit. But I will change that out. And this 100K here, like I say, is not on the schematic. So I may not even bother with that. I want to get the electrolytic in. Get these hooked back up, and this one replaced. Get the cord on it, and we'll see if we get any life. That will be in part number 3. This concludes part 2.